In this video, we are going to talk about the derivative of trigonometric functions. So let's talk about derivative of trigonometric functions, right? So basically, we will talk about how to find the derivative of trigonometric functions. So the very first formula that we'll talk about is d by dx of tangent x is equal to secant square x. My second formula would be d by dx of cotangent x is equal to negative cosecant square x. Our third formula for the trigonometric function is d by dx of secant x is secant x times tangent x, and my last formula is d by dx of cosecant x is equal to negative cosecant x times cotangent x, right? So as you can see, we have four trigonometric functions and we are finding the derivative of these four trigonometric functions. Now let's consider an example. So my example is find d by dx of secant x plus tangent x, right? In order to find the derivative of this function, what I'm going to do, I'm going to distribute my d by dx inside the bracket, and if I do that, I will write this is equal to d by dx of secant x, because secant is my first function, plus d by dx of tangent x, right? Because secant is my first function and tangent is my second function. Now, if I use the formula for the derivative of trigonometric function, I can easily see that d by dx of secant function is secant tangent. So I will write d by dx of secant function is secant x tangent x plus d by dx of tangent function is secant square x. So I will write secant square x. Now, as you can see, secant x is common, so I'm going to take secant common outside. So I will write secant x, and if I take secant out from here, from the first part, or I should say first term right here, you can see only tangent is left, so I have tangent plus, I have a secant square over here. So if I take secant out, I am left with secant x, right? So basically, the derivative of this function right here is secant times inside the bracket tangent plus secant. Now let's consider another example. So my example is find the derivative of d by dx of cotangent x plus cosecant x, right? Now, in order to find the derivative of this function, what I'm going to do, I'm going to distribute d by dx inside the bracket, and if I do that, I will write this is equal to d by dx of cotangent x, right, plus d by dx of cosecant x. Now, I am going to use the formula from here. So as you can see, d by dx of cotangent x is what? Negative cosecant square x plus dy dx of cosecant x is negative cosecant x times cotangent x. Now let's simplify further, and if I do that I will write this is equal to negative cosecant square x, and then I have positive times negative is negative, and I have cosecant x times cotangent x. Now as you can see, I can take out cosecant x common because I have cosecant x as a common term, and then this negative also. So I'm going to take negative cosecant x as a common term, and if I do that I have cosecant left with the first term plus, because I'm taking that negative out, and only thing left is cotangent x, right? And this is basically the derivative of this function right here. Now let's consider one more example. So my example is find dy dx of tangent x plus cotangent x, and we all know that if I want to find the derivative of any given function, I am going to distribute dy dx inside the bracket, and if I do that I will write this is equal to dy dx of tangent x, right, plus this plus sign dy dx of cotangent x, right? And we all know that dy dx of tangent function is secant square x, so I will write secant square x plus this plus sign, and dy dx of cotangent is negative cosecant square x. Now let's simplify further. So if I simplify further I will write this is equal to secant square x, and then positive times negative is negative cosecant square x, and this is basically the derivative of this function tangent x plus cotangent x. And this is how we will find the differentiation, or I should say the derivative of any given trigonometric function.